Now let's put everything together, find zeros of polynomial functions, and then we're going to sketch the graph of the function. So first we're going to find the zeros of f of x equals negative 2x to the fourth plus 16x squared minus 32. So we need a factor. So always look for a GCF first. What can we divide out of every single term? Let's go ahead and divide out a negative 2. So no variable that we can take out. So when we divide out a negative 2, write it to the front. Then we're left with x to the fourth, negative 8x squared, and then 2 goes into 32, 16 times. So then let's factor. Let's factor using the x method. So what multiplies to 16 that adds to negative 8? Well, that's negative 4 and negative 4. So negative 4 times negative 4 is 16. Negative 4 plus a negative 4 is negative 8. So this is in a quadratic form. So remember that when this is, if this is to the fourth power, as long as this number in the center is half of this 4, and it is, right? Half of 4 is 2. Then we just split it up. So this is x squared and x squared. Now, just to go back and think, x squared times x squared is x to the fourth. That's why that is okay. So then we factored it. A is 1, so negative 4. So let's plug in the negative 4 and negative 4. Now looking at this, we can factor this further. This is a difference of two squares. So remember, when there is a negative in the center, and we can square root the first and the second term, then we can go ahead and use a difference of two squares pattern. So negative 2. So this first one is square root of x squared is x, and square root of 4 is 2. And remember, there are opposite signs in the center. The same is true for this because they're exactly the same. So let's do it again. So square root of x squared is x, square root of 4 is 2, and a plus and a minus. Now previously we talked about repeated roots. So let's talk about our solutions first of all. So we have an x. So remember, you do the zero product property. X plus 2 equals 0, and x minus 2 equals 0. And so you solve for x. So therefore x equals negative 2, and x equals a positive 2, because you add 2 to both sides. And then this is just repeated. So this is a repeated root. It is actually squared. Okay, so it's even. So it repeats with an even root. And let's talk about what else do we know. So the x-intercepts we know is that x equals negative 2, x equals 2. Where is our y-intercept? Remember, the y-intercept is when we make x equals 0, or it's just a constant at the end of the polynomial. So looking here, if we plug in 0, notice that the x to the fourth, x squared would go away, right? Because 0 times negative 2 is 0, 0 times 16 is 0. And we're left just with the constant of negative 32. So our y-intercept is at y equals negative 32, or we can write that as 0, negative 32. The end behavior. So we look at what is the degree of the polynomial, what is the degree, and what is the sign of the leading coefficient. The degree is 4, so it's negative 2x to the fourth. The degree is 4, so it's even. The leading coefficient is negative. So if the degree is even and the leading coefficient is negative, are the ends going to go the same or opposite direction if it's even? Well, it goes exactly the same, and leading coefficient is negative means it points down. So we can sketch this. Now I know I have a grid here, so let's go ahead and use a grid for now. Later on, we can just do a general sketch. So we know that we have a y-intercept at negative 32. So I'm going to draw my axes here. So negative 32 is going to be about right here. Here, negative 32. So if we count, that would actually be negative 32. So that's our y-intercept at negative 32. Then we have x-intercepts at negative 2 and positive 2. And those are repeated. Okay, those are repeated with an even root. Okay, because it's twice, so we see that, those roots. Then because the end behavior is down and down, we know it's going to go down and down. So it's going to bounce at these two places. So to sketch this graph, start from the bottom, then it hits that spot, then it hits again right at the y-intercept, goes back up, hits it, and then goes all the way back down. So we're just looking at sketches of these graphs. So again, you just graph the x-intercepts, the y-intercept, and then you look at the end behavior. So try out number 3 and number 4. So you want to factor it first, and then find the x-intercepts, and then the y-intercept, and then look at the end behavior to help finish your graph. All right, if you try this out, so first you need to factor it, so let's divide out of 3. So when I divide out of 3, I'm left with x to the 4th minus 2x squared plus 1. Because this is x to the 4th, and that's half, I just split it up as x squared and x squared. Then to factor it, so what multiplies to 1 that adds to negative 2? What's negative 1 times negative 1? So then you just write it inside. So you write the factors, negative 1 and negative 1. So you write x squared minus 1, x squared minus 1. Remember, I can square with the front and the back. This is a difference of 2 squares for both. So then that factor, so you'll get 4 different factors. You have 3 times x minus 1 times x plus 1 for this first set, and then it repeats again, x minus 1, x plus 1. So I went ahead and rewrote it this way. So we have 3 times x minus 1, and that's squared because there's 2 times that it happens. X plus 1 also to the squared because it's twice that it happens. Now because it's even, it's raised to an even power, that means it will bounce at that point. It's not going to cross the x-axis. Then we look at the x-intercept. Remember, you set it equal to 0. So x minus 1 equals 0. And x plus 1 equals 0, right? We're just using the zero product property and you solve for x. And some of you can do this without having to do this step, which is fine. So notice the x-intercepts are at 1 and negative 1. Our y-intercept is this beginning 3. So we know that it hits the y-axis at 3. So I put 0, 3. The leading coefficient is positive. The degree is even. So I know that the ends will go up and up. Okay, even goes up and up, same direction and positive. So then I knew that if we started up here that it's going to bounce at the negative one, at the positive 1. It's going to pass through at the y-intercept of 3. Then it's going to bounce again at negative 1. So those are the only points, are the only places that this graph will touch the x-axis, okay, or cross, for example, if we had to cross. Now if you try the next example, number 4, so you divide out an x, you factor in an x, so then you're left with x squared plus x minus 6. Then use the x method. What multiplies to negative 6? That adds to 1. That's 3 times negative 2. So it's only squared, so we just write x and x, right? It's that same degree right here. So then x times x plus 3 and x minus 2. So that means we have a 0 at x equals 0. Then x equals the negative 3, right? Set it equal to 0. It's negative 3. Then x equals positive 2. So those are my x-intercepts at 0, 2, and negative 3. And none of them is repeated, right? There's no powers here. It's not repeated even or odd. Well, it's odd, actually. And so we know it's going to pass through at those points. The y-intercept is at 0, so there's nothing here, right? And we realize that x equals 0. When x is 0, our y is also 0. So there's our y-intercept. Our leading coefficient is positive. Here, there's just a 1. And then the degree is odd, third power. So we know that it goes in opposite directions, and it goes up on the right and down on the left. So therefore, I know it starts up here. I'm going to pass through at the positive 2, then go back up, pass through the 0, and then pass through again at the negative 3, and it continues to go down forever.